Okay, so thank you very much, and thank you very much for inviting me here tonight to give this talk. So, yeah, this talk is going to be quite wide-ranging. It's going to be from meteors to micrometeorites, with a not too subtle plug for my website, Micrometeorites.com. Okay, so as mentioned, my name is Steve Grimes. I'm a lecturer here at the university, but by training, I'm an isotope geochemist. So I use isotopes, stable isotopes, to study geochemistry, and in particular I study past climate change. So the whole of my career to date has been looking at how the Earth's climate has changed over geological timescales. Okay? And I've been here now for 20 odd years, okay, as a lecturer. The idea was I was going to come for a few years and I was going to go somewhere else, and I decided to stay. Okay, etc. So I've been here for 20 odd years, and my day job is looking at, as I said, climate change in the past, so the geological past. Okay. And as part of that, I've had the opportunity to visit some wonderful sites. So these photographs here of a site in Spain called the Paris Conglomerate, as part of something called the Paleocene-Eocene thermal maximum, which happened about 35 million years ago, and was a really important change in the Earth's climate. And while I've enjoyed doing that, okay, like the cartoon says up here, okay, at some point when you hit your 50s, like me, okay, things become a little bit too routine-wise, okay, and you start thinking, actually, I want to do something else in life, okay. So as Snoopy is saying here, okay, my life has become a little bit of a bore. Everything's the same day in, day out. No disrespect to my students here, okay? It's not you I'm talking about, it's the research that I do, okay? So I need a change. So as Snoopy said, he's changed. And I decided about a few years ago to make a change myself. So I swapped my orientation. I decided to do something different in my life, okay? Part of that was driven by a good friend of mine, who I won't embarrass, but she is here tonight, who has been working as a space geologist for years. Okay, and through my friendship with her, I developed different interests, and it started off more as a hobby, okay, which I developed because I got bored. I've got teenage kids. Okay, I wanted to do something different in my life, especially during the weekends and stuff, and they grew out of interest in dad and doing stuff. I decided to want to do my own thing, and that hobby developed into a research interest. And that research interest is something I now work as part of my career here at the university. So what I'm going to talk about today is those two aspects of my life. So the first is the global meteor network, okay, which was the hobby side. So what is it? How did I get involved in it? And essentially what does it do? Okay, why is it important? And then I will connect into the other part of my interest, which is micrometeorites. So what are they? How did I get involved in them? How did I collect them? And importantly, why are they important as well? So that'll be, so the talk's in about two halves. Both are connected with this website because as an academic, I'm really interested in communication. So yes, there's scientific research and we publish in scientific journals, but there's actually outreach and citizen science, which I'm really interested in as well. So I decided to create a website. I've never created a website before. I thought I'd give it a go. It can't be that difficult. And it actually isn't that difficult there's lots of tools now that help you do that. So I created a website called Micrometeorites.com because I wanted what I do as part of my hobby, but also my research, to be available to the general public and to actually encourage people, members of the general public, to be involved in this research as well. Okay. So there is a website. It has a lot more in it than I'm going to talk about today, but please, if you've got time, have a visit of it because it will give you a lot more information I can give you during this talk today. Okay. So let's start off with the global meteor network. Before we get there, just to clarify a few points, majority of the audience here will probably realise this, but for those that don't, okay, there's lots of material out there in space, okay, they can be classified into a number of different categories, okay. Of course, comets and asteroids are out there. I'm talking about planets, but suns, etc. But comets, asteroids, meteors, which is I'm going to talk about to start with. So these are when a meteoroid has entered the atmosphere and started to burn up, otherwise known as shooting stars. Okay, fireballs. Now these are meteors, but of a certain intensity. So if they are large enough, they generate what's called a fireball. And then if they eventually, these fireballs or meteors make it to the ground, okay, shooting fireballs, then you have a meteorite, okay, that's the stuff that lands on the Earth, okay. And that's the bit that's going to be the second part of my talk. Not the meteorites themselves, but actually the micrometeorites, and I'll explain what they are later on, okay. Just out of interest, if you ever do find a meteorite, I'll be very jealous. I've never actually found a meteorite myself. Okay, I found lots of micrometeorites, but a meteorite itself. If you ever do have the opportunity and you find one, okay, then a bit of advice about what to do with respect to find them. Okay. Most important thing is ideally don't touch them because they're not. It's not that they're dangerous, because we don't want you, for scientific reasons, to contaminate them with your hands, so put some in your hands, etc. And please do not stick a magnet on it, okay? Not all meteorites are magnetic, okay, and they'll give you a false diagnosis, okay? So if you suspect it is a meteorite, please collect it, okay? Record where you've got it from and stuff, and then, rather than sell it on eBay, please let the scientific community know about it, because it can be really important scientifically, okay? Just as a couple of fillers here, here's a couple of meteors that I photographed, but these were with my Canon camera, okay, rather than with the Meteor network cameras. So what is the Global Meteor Network? Well, this is a citizen science-driven network or initiative, okay, which does feed into some scientific research, okay, but is essentially organised and run by citizen scientists. So, a bit like you and a bit like me, okay? And the idea, and it has a rather, let's say, I don't want to say exaggerated aim, but quite a strong aim, okay, of no meteor unobserved. Okay, so the idea is that there will be cameras globally that are looking up at the sky and will record any meteor or shooting star that enters the Earth's atmosphere. Okay? As you can see by this map here, the no meteor observed is probably a little bit of an exaggeration, okay, because each of those little blue or white dots, okay, represents the camera network globally. And as you can see, that there is quite a good concentration of cameras in and around Western Europe, okay. UK, remarkably, is one of the most densely covered camera networks. So if there was a part of the world where you could probably say, assuming it's a clear night and all cameras are working, that no meteor will be unobserved, okay, it's probably the UK. Okay? As I'll say later, there's over 250 cameras spread across the UK, all looking up at the sky. Okay? And then Western Europe, because we link in with other meteor networks, okay, over Western Europe. And then there's these concentrations over in the west of the US. Interestingly, New Zealand is really keen on meteor cameras, so there's a good concentration in both the South Island and North Island. And then over around about Perth, okay, Western Australia, there's a good concentration of cameras over there. And I'll talk about the science a bit later, but the idea of this meteor network is, yes, it starts off as a bit of citizen science, a bit of fun, okay, with me. I just wanted to build something and look into the night sky and see what I could see, okay. But it does feed into some scientific research as well, okay. Looking at meteor fluxes, trying to determine new meteor outbursts or showers, etc. Okay, so not on the order of the, for example, the Perseid meteor shower, but smaller versions of those. Okay. So it's a global network, but in the UK there is a UK arm of the Global Meteor Network. Unsurprisingly, that's called the UK Meteor Network, okay, or the UK MON. Okay. And yet again, it's run by citizen scientists. Okay, we've got we've got people in there from. These people are really helpful. Okay, computer scientists who know how to code. Okay, up to people who are really keen on outreach and involved in the community. But also there's some scientists in there as well. But school teachers, or a whole range of different people. Okay, it's not a scientific, academic-based network. Okay, and these are where the distribution of cameras in the UK. Okay, so we're here. Okay, so this is me, or my camera's down here in Plymouth, and there's a number of others in the southwest, but concentration in the Midlands as well, and further up into Scotland, and then over into Northern Ireland as well. The important thing is that each of those locations doesn't necessarily just have one camera. As you'll see in a minute, okay, with my network, which is not atypical, each of these locations may have cameras pointed in different directions. Okay? And actually a lot of them have multiple cameras located. So, how do you get involved with the UK model? Well, I'd never heard of it, okay, until my colleague mentioned it to me, and like everything else, I thought, what's that? And I went home and I Googled it, and I thought, this sounds interesting, okay. And I reached out to the community at the time. This was about 5 or 6 years ago, and I said, look, I'm kind of interested in doing this. My birthday's coming up. Okay, and somebody's willing to buy me some equipment. Okay, so about 5 or 6 years ago, when I started, the network actually you paid a fee, but they sent you the kit, so to speak. Okay, unfortunately, we can't do that now because there's a new law on surveillance or something, where if we provide information, they provide equipment to you that is considered monitoring in nature, okay, then there's a whole series of regulations associated with that, so they've had to stop providing the kit itself. But they nicely provide you with a list of all the parts and where to buy them on either Amazon or other websites, etc. And then you could buy them, and you can assemble through instructions the network itself. Okay, so it looks a little. So this is my setup here on my house. Okay. Okay, this is the dormer window at the top of my house, which happens to be on a hill with quite a nice view over Plymouth. Okay, I've plastered my dormer with these cameras. Okay, my wife was a little bit worried that when we move house, I'm going to have to take all these down. This dormer window is just going to be covered in holes. All these holes will be screwed. But, so they send the equipment. Essentially, it looks like a, I don't know, 2000 security camera that you maybe have on the front of your house before the Ring door things became popular. Okay, you've had this big camera set up. So it looks a little bit like that. So you've got a camera case here, you've got an attachment here that attaches it to your house. You've got the actual camera itself. Okay, or the board itself with a sensor in it, and you have a lens which attaches to it, and that's the details about the camera and the lens that we use. And you essentially build this kit inside the system, connect it all up, and connect it to wherever you want to put it on your house, looking up at the sky, and then power over Ethernet cable runs to wherever you have got your computer. And the idea of the system is it's meant to be as simple as possible, so a Raspberry Pi 4 or a Raspberry Pi 5 is the system that it runs off. And you download the specialist software, which is a global Meteor network software, which runs on that Raspberry Pi, which essentially controls the camera and the capturing of the images, etc. Okay? So it's designed for non-specialists, which was helpful for me, because I was a non-specialist in this field. Okay, I've never done electronics in my life. Okay, building a camera network like this was completely new to me. I know nothing about Python coding. Okay, so it's nice to download a piece of software, put it on my Python, and just press go, so to speak, and the system working. And as you can see, I started off with one camera. Actually, it wasn't here. It was here to start with, and then decided it wasn't the best place to put it. So I moved it up to the higher, up on the house with a better view, okay, of the night sky. And then next year, my birthday came around again. That's what happened. Okay, I bought another camera. Well, I got another camera bought for me. And after 3 years, I decided I had 3 cameras, all pointing in different directions. So this one essentially points east. This one points west. This one points kind of northeast. I don't have one yet on this side that's pointing south. Okay, mainly because there's a great big block of flats here. Okay, that you can't see, so it wouldn't be a particularly good view. So I'm restricted to my view. But I've got quite a good coverage. So this is my coverage at 100 kilometre altitude across the UK. So my cameras in theory and have captured meteors that are flown across southern Scotland, parts of the Irish Republic, okay, and over in France, as well as the majority of the UK. Okay. So I've captured cameras over quite a distance. Okay. Once you've set up your system, okay, which is relatively straightforward, if you have problems, you can always contact the group and they will give you advice, either coding advice or technical advice with respect to the equipment. If you're struggling, they provide all that advice that you need. Okay. For my students, okay. Yes, this is a ladder coming out the dormer window. Yes, this is me sitting on the ladder outside the dormer window. And yes, I did fill in a risk assessment before I did that. I didn't know you would be here. Okay, so I wasn't going to put that in. Anyway, once you've got the camera set up, you have to, before you can actually start contributing, for the first night, you can capture images. It will capture images, and if it sees meteors, it will capture images for it. So the software runs itself, okay? It knows what to look for, and you will have a series of captured and detected images, okay? So the software will work, it will capture everything, but it will work out what it suspects is a meteor, and it will put that into the detected file. But before you can actually start contributing to the UK Meteor Network and then the global Meteor Network, you need to first of all create a mask. Okay, so essentially this is my roof. This is the one that's looking west, back over my house. This is my roof. Okay, you have to create a mask which essentially says ignore everything that happens in this zone here, because that's a physical object. Okay, now that's my roof. In other people's, it could be a hedge or a tree, whatever. You just need to mask that out. Okay. If you've got a tree, you have to update your mask regularly because, contrary to popular belief, okay, trees grow. Yeah. Okay, so your mask you have to constantly adapt your mask or trim your tree to match or your hedge to match your mask. Okay. Once you've done that, the most important thing is you need to calibrate your camera with respect to the star chart. Okay, because and I'm not going to talk about orbital dynamics, okay, about how we work out trajectories, etc., for multiple cameras, mainly because I don't really understand it. Okay, I don't really want to go there, okay? But I know enough, at least, to work out that your camera, because the night sky changes every night throughout the year, as you're all aware, okay, you need to calibrate your camera to a star map, okay? And that's essentially what we do here. And once you've done that, and everything's submitted to the UK Mon, they will allow your camera to go live and feed in to that data set. Okay. So once it's gone live, you've done all these things, and you've climbed out on your roof or halfway up a ladder or whatever you want to do, okay, and you've installed, okay, your camera will start collecting information. And there is not a night that goes by, if there's a clear sky, the cameras are so sensitive, they will capture meteors, okay? The only thing that really stops us capturing meteors on camera is the weather, okay? If it's cloudy and there's not enough stars, okay, to calibrate weather. Every other night you will capture. So these are a couple of single images. So this is a fireball, okay, from the 13th of March 2025, okay, which was actually reported over Plymouth. So lots of people actually saw this, okay. There's another one down here from September, the smaller fireball, okay, here. as well. And then what this photograph is, this isn't like really lots of meteors arriving at the same time. This is actually a compilation of 112 meteors from the peak of the Perseid meteor shower in 2024. So in that night, my camera caught 112 different meteors entering the atmosphere, okay? Including a couple of three small fireballs as well. Okay? So the capture, the cameras are really sensitive and really good at feeding into this. But in addition to just finding things that are flying over well, they're actually not flying over your house, they're actually probably at a huge distance away, okay? Rather than just capturing those single things, what the network does is they capture images from multiple cameras. So this is a report from 2025, so this is the 13th of the 3rd, 2025. This is a report, so this is a daily report, so you receive daily reports if you're part of this network. And any meteor that's captured, so in this case, I caught this meteor on my camera. And you can see that's the track of the meteors, but these are all the cameras around the UK that also captured that same meteor at that same time. And using the multiple cameras throughout the UK, what they're able to do with black box science, okay, is work out the orbital trajectory of that meteor. So to work out whether it's a sporadic meteor, okay, or whether it's part of a meteor shower, okay. They're able to do a number of other things as well. So in the daily reports, I'm not going to go into the details here, but in the daily reports, they can work out also this becomes important later, not only the trajectory, but also the altitude at which that meteor reached, okay, before it burnt up. Okay? So it's great fun. I like reading these daily reports, okay, seeing how many meteors are coming in, okay, whether my camera was part of that detection, etc. Okay. But these cameras are on all the time, okay? So they capture anything that's happening out there in the night sky. So this is what we call a capture stack, okay, rather than a detected stack. And literally, this is a meteor here, okay? But it captures everything else. So a couple of other meteors over here, but it captures planes, okay? Rather annoyingly, it's very good at capturing Starlink satellites. Yes. It's really good at capturing those, okay? But the other thing it's really good at capturing is you can recognise, you probably see this thing here. I don't get many of them where I live, but a lot of cameras, especially if they're in in more rural locations, their capture stacks are full of these traces here. Anybody want to guess what that possibly could be?
What's on there? The bats?
The bats, yes.
Up there.
Yeah, so it's actually a different way to detect that one. They're actually bats, okay? So it actually can capture bats as well. And I'm trying to develop this project with some of my colleagues about actually using this camera network, because all the data is freely available, it's captured and it's freely available, about using it to monitor bat populations in the UK. Nobody's kind of taken it up at the moment, but I think there's a project there. The other thing it captures as well, and this is quite unique, okay, is this, I've only ever captured one of these, okay, so I thought I'll throw it in here. It actually captures something referred to as sprite lightning. Now this is really unique lightning that's, you're all aware of fork lightning, sheet lightning, everything that comes down. Actually, there's a form of lightning that literally goes up. So it goes up out of the Earth's atmosphere, the mesosphere, upwards, okay? And they're usually associated with really intense thunderstorms. And it's at the top of the head of the thunder cloud, the lightning literally goes upwards. And these cameras are really good at spotting those as well. Okay, so this was for 2023, and this is actually a thunderstorm that's happening over northern France that my cameras picked up, this bright lightning. And there's actually a website, I found out, a website where you can contribute data associated with bright lightning as well. Because as I said, one of the things I'm really interested in, not just doing this for fun, but doing it for scientific reasons and contributing as well. So actually that's part of that data as well. Also, in 2024, my camera picked up, this is all of those images from that night. They picked up these really strange lights in the sky. Actually, look like clouds in the sky. Just happens, by sheer coincidence, I had a Canon camera stuck out that window as well, okay, pointing north, okay, and what it captured was this, okay. And this is what the Meteor camera captures as well. It's the Aurora Borealis, okay, in Plymouth, okay. It was one of the most, in 2024, it was one of the most intense storms, electromagnetic storms we've had, okay, and it was viewable from as far south as southeast. There was an equivalent storm 2 nights ago.
Yeah.
What was it doing in Plymouth? It was absolutely cloudy, yeah. So I had my camera ready to go out again, but we didn't manage to capture it. But in 2024, I did, and yeah. So the cameras themselves, and there has been a talk within the network itself as well. Why don't we switch from black and white cameras to actual colour cameras? Because we could capture all these really exciting other things as well, like the Aurora Borealis, especially if you're in the Midlands or northern Scotland as well. And it was looked into by the network, but what they found was actually the quality of the data that was captured on the meteors itself was reduced. The colour cameras weren't as sensitive as the black and white cameras. So for it's a meteor network, so they decided to stick with the black and white cameras. But it still captures stuff that's happening out there. And as I said, the network does have a lot of interest from citizen scientists like myself, who was just interested in building something, putting it in the sky and seeing what you could see, okay, but also supplying data. That data that I supply, okay, does contribute to scientific publications. And this is the 3 pages of acknowledgements. But I am there, okay, look, it's me there, okay. I am part of this paper that was published on the upper limits of interstellar meteoroid flux at video scale, okay. So the work that I've contributed to do does have a scientific purpose, okay? And there's other ones as well, so that's with respect to how cameras are good. But as I said as well, also you get these papers coming out every now and then, and they use the Global Meteor Network data set to discover new potential meteor showers, okay? They're not of the scale of the major 5 meteor showers per year, but there's enough data to indicate that these are minor meteor showers associated with them. And the networks connected with that. From my perspective, I don't know why I'm carrying this thing around, it doesn't actually do anything. From my perspective, the real reason why I set up my cameras for the Global Meteorite Network was I'm not really okay, don't tell anybody in the Global Meteor Network this, okay? But I'm not really that interested in finding new meteor showers, okay? What I want to do, I've always wanted to find a meteorite, okay? It's what drove me to do this, okay? And the Meteor Network does provide information for this. So you may remember in 2021, the famous Winchcombe meteorite came through, okay, and it literally landed on somebody's driveway, or part of it literally landed on somebody's driveway, okay? Luckily enough, the daughter here, she's doing geography, yeah, and she recognised it for what it was, so preserved the site very quickly, and then contacted the Global Far Network, who sent out people to actually collect the sample. But what they did in addition was they thought, right, we've got the obvious one that's landed on somebody's driveway, but there's going to be other material that's fallen in the surrounding area. And they used the Global Meteor Network and the camera track, and it's the track of the meteor, okay, to work out potential fall areas. And they went out into that community, into that area, and Matt here was part of that team that went out there, and they literally walked the fields, in lines, and they found additional material here. So here's one that literally landed in a farmer's field as well, and they managed to collect additional material. And the reason they could do that is because they had a fall zone determined from that global regional network. And that's the bit that really excites me. Okay? Unfortunately, I wasn't set up in 2021, okay, so I couldn't actually contribute to this. More recently, okay, there has been another fall. This has made the news. There was one in Scotland. Okay, so this came down, and anybody fancying a little hike up into the to the Highlands, okay, we have a fall zone, okay, where you, if you fancy doing any of these, what they call them, Monroes, you capture your mountains, okay. If you're up there, okay, and you're walking around, please look out for meteorites that have landed. Unfortunately, it's probably the most remote area in the UK. So the Farball network didn't actually do a search there. Oh, actually, some people from Glasgow Uni actually went out and looked in a few obvious places, but they didn't. They didn't go right out into the countryside. But it contributes. And there's another 3 or 4 I could have mentioned to you. There was one in the east coast of East Anglia, which is a recent fall as well. There was one in the New Forest. Okay. The problem with, unless it lands literally on somebody's driveway in the UK, is it's really difficult to find meteorites. So I'm hoping one lands on Dartmoor, because I'd just love to go up and look for it. But I realise looking for a meteorite on Dartmoor is going to be an absolute nightmare. It's the literal needle in a haystack. Okay. So, when I realised I couldn't actually find, or I hope in the future I will be invited, if there's the members of the Global Meteor Network get invited onto these searches, if it's in the area, the fall is in the area that your cameras are in. Okay, so that's why I said I'm really hoping well, fall was in the southwest, because I'll get invited to go out as part of the search. Okay, but I've realised that chances of that happening is as low. So I thought, well, where can I find other meteorite material? I want to get my hands on a bit of space material. Okay. And I heard about these things called micrometeorites. And this is a micrometeorite here, okay? I will talk a little bit about it in a minute, but these are small versions, as that name suggests, it's a small version of a meteorite, okay? So what are micrometeorites? Well, the first thing to say is they are not, this is important to note, they are not the fragments of meteors that have come through the atmosphere. Micrometeorites are not broken up parts of a meteorite, okay, or a meteor going down from the sky. What they are is their own size classification of material. So in general, they're about 1/4 of a micron in size, so about 250, 300 microns, okay? And that material is essentially space dust. So out in the solar system, in addition to all these big bodies, you have essentially space dust, which is broken up, comets, broken up old asteroids. Okay? And this stuff is flying around it's in the solar system, and the Earth is passing through these all the time. And they make it through the atmosphere because of their low trajectory, because of their low velocity and small mass. They make it through the atmosphere and land on the Earth. So it's literally raining down all the time. And it's estimated, based on flux calculations, that about 5,000 tons of these micrometeorites fall to Earth all the time, okay? Every year. And that equates to about 14 tons per day is raining down on the planet. Not in one spot, but globally around the planet. Okay. So, where do you go to find micrometeorites? Well, some of the first ones in the 1800s were actually found as part of sediment that was collected from the oceans. But after that, the largest collection of micrometeorites were actually collected from Antarctica, which is exactly the same place you go, one of the same places you go to find meteorites themselves. Okay, you go to Australia. Okay, I can collect them in the deserts there, but looking for black objects on a white background, aka snow ice, is really easy, so Antarctica is a place to go. But they also find micrometeorites there as well. And because this dust is raining down all the time, it's blown around and it falls into they call them sediment traps, or essentially cracks in the rock. They fall into that, okay, and you can go and dig out this sediment and find lots of micrometeorites in there, okay? You have to go to the dry valleys, okay, because that's the place where it's easier to get atmospheric dust whipped up by the winds and trapped in these crevices, okay? So, of course, I went to Antarctica to look for my micrometeorites, okay? I kind of went outside of the building I worked into and looked up. And I thought, I've got these huge sediment traps, okay, which are called roofs, okay, all over the campus, okay, which are collecting stuff that's raining down on them, and it's just settling on the roof, okay? And if you have a little bit of rainfall as well, which I know it's rare in Plymouth, but if we have a little bit of rainfall, it washes that material towards the drains or towards collection areas, and they stay there. And you can literally go out and sweep this stuff up. Now, there's lots of non-micrometeorites in there, but if you're careful enough, you can look for them. And urban, as they're called, urban micrometeorites were considered to be a myth until about 10 years ago, just over 10 years ago, when the first ones were actually formally identified, okay, in Norway, from material that's kept on the roof in Norway. And since then, the whole science has exploded as a citizen science project. These micrometeorites are found everywhere in urban environments. What makes a good roof? Not Portland Square, because it's an asphalt roof, okay? So you've got loads of rocks, okay, or minerals, okay, embedded in tar, okay, bad roof, okay. What makes a good roof is one that's essentially a smooth roof, okay, or, more importantly, one that's got a slight angle to it. So the material can flow down that roof and collect in a gutter, okay. So one of my most best collection sites is this location here. This is it's a place called Secure Innovations over in Saltash. Okay, and I found 8 micrometeorites now from the material I collected out of their roofs. Okay, you have to contact the companies, and the companies are a little bit dubious about you to start with. So for every 10 emails I've sent out, I've probably got maybe 1 reply. Okay, usually they think I'm mad and they just ignore me. Okay, but sometimes they get back to me. And I've even this helped with the contact that Matt gave me. This is Scoot Hilly down in Cornwall. Okay, and I thought this is the Centre for UK Space Space Science, not space science, but observation. I thought it'd be great to find some micrometeorites on the roofs down there. And I went down and they helped me collect some samples there. And yes, we did find some micrometeorites. Okay. So, quick question to you all here quickly. Anybody work for a company with or got a house with a really big roof? You speak to me afterwards, because I love to come and collect some material without without having to contact people. So, once you get this material, you have to dodge the seagulls, especially in the southwest. Okay, if you're on these roofs, sometimes you collect all this material, this sediment from the roofs, and then you essentially sieve it to a size fraction, because micrometeorites on average are about 250 microns, but can go down to about 100 microns, just less, up to about 500. So you sieve within that range, and you get lots of sediment. So here's a load of sediment here. Now, the majority of micrometeorites are, as I'll explain in a minute, are iron magnesium silicates, and the iron is key because it means that they're magnetic. So what you can do is you can reduce this amount of sediment, picking through this amount of sediment, to something like this, and a bit more, by using a strong neodymium magnet, and just passing your sample under that, because it sticks to the magnet, get off the magnet. Doing this, I didn't realise there's a whole hobby out there called magnetic fishing, where you get these neodymium magnets, and you chuck it into a river, and you bring it back in again, and you pull up just magnetic stuff. I wouldn't do that in the southwest, or anywhere that's potentially been under attack from years gone by. You never know what you're going to pull up, okay? So please don't do that. But they're great for searching for micrometeorites. And then once you've got this reduced sample, you literally have to, with a low power microscope, go looking for this material. Okay. And I have a number of students each year who are more than happy to go searching for these micrometeorites for me. Okay. And then once you find them, and I'll talk about the different types of them in a minute, once you find them, you can photograph them using just, this is a simple Canon, I think it's a Canon setup with a zoom lens here, okay? You can photograph them, you get these most amazing images of these extraterrestrial rocks, okay? And some of the people who have worked in this field actually create artwork out of these, because they have the most amazing morphology structures to them, okay? To get the full three-dimensional, it's a bit like when you're photographing in the sky, you have to stack images on top of each other. So you focus down here, and then you build up a stack, focusing up to the top, and then you stack it all together, and you get these most amazing three-dimensional or images of these spherical objects. Okay. And this is part of the John Larson project here. Okay, they're taking those photographs. Because I work at a university, I have access to toys that a lot of the scientific community, the citizen science community don't. So I kind of skip that step. I just stick my samples in the scanning electron microscope, okay, because you can do a lot more in a scanning electron microscope than you can just by taking normal photographs. Okay. So this is a benchtop SEM that we have in our school, which I use all the time. Okay. But we also have more sophisticated equipment up at the Plymouth Electron Microscopy Centre as well. So yeah, I have access to their analytical equipment up there as well. So what have I found? Well, I literally have found let's be careful. Not every roof I've looked at I found a micrometeorite, but majority of them I have. So I found micrometeorites on the library roof at the University of Plymouth. As a secure innovations, I found micrometeorites there. BD. That's up by Roborough. It's a large, it's a large industrial complex up there. Okay, they let me on their roof up there. They said they would only do it once. Yeah. Okay, and that was it. Okay, so, but I found a number up there. Kawasaki. There's a big plant out there. It's got a flat roof, infested with seagulls. But between the seagulls, managed to collect some sediment there. And we found some micrometeorites there. And Goonhilly as well. That space centre out in Cornwall. I've got micrometeorites. Now, all the micrometeorites I have found are what we refer to as S-type micrometeorites. So they're silicate-type micrometeorites. And if you were to classify them to their original meteorite composition, they're what we call carbonaceous chondrites. Okay? So not involved in planetary formation processes, so comets and asteroids, etc. Okay? And all of the S-type micrometeorites are subclassified depending upon the amount of heating they've experienced as they've travelled through the atmosphere. So you get these scoriaceous micrometeorites, which have the lowest temperature of heating. Okay? Usually they're full of gas pockets as well, so they're quite nice to see they're full of all these holes where gas has escaped. Okay, and you've got these. This is essentially holy. Then you have the porphyritic, which to geologists that means something with respect to English geology. In other words, you can see the original crystalline minerals in there. So here's some of those original olivine crystals there, and there's a thin melt drape over it. Then there's a group of what we call barred olivines, which have melted, but has recrystallized into these essentially these plates, which forms a unique structure. Then the cryptocrystalline, and a subcategory which I love of the cryptocrystalline, which looks like this. And if you were to imagine an animal, what does that shell look like of an animal? Which animal has a shell that looks a little bit like that?
You stick to rocks and cut them.
Limpet.
Sorry? Limpet, yeah, I think it's a more land-based. Sorry? Turtle, yes. And they're actually classified as turtleback. So this is cryptocrystalline turtleback, because actually the structure looks like the back of a turtle, normal turtleback. Okay? So there's two classifications of cryptocrystalline, normal cryptocrystalline and turtleback. And then there's the vitreous, which is essentially completely remelted, okay, and then re-solidified as well. Okay? But all of them have this unique spectrum. They are iron, magnesium silicates, okay? Regardless of which category they are, because of their melting and recrystallization, they're all iron, magnesium silicates. So these are all what we call S-type micrometeorites. Okay?
So a quick question, if I may.
Yep.
So these are different just because their process is coming through the atmosphere?
Yes. So they're classified based upon the secondary alteration of them as they've heated up coming through the atmosphere. There is a category that I haven't put on here because I don't have one of them. These are all my micrometeorites, by the way. There is a category down here which is unmelted. So it's been heated up during atmospheric entry, but the heating has not been enough to actually melt any of the original constituent content of that micrometeorite. Okay?
So that's how you can tell the temperature.
So we can tell the temperature by the essentially what is the secondary alteration of the material. Okay? I'll explain that in a oops. Okay, so this kind of puts it into a bit more perspective. So what happens when these things enter the atmosphere is A, they melt, so there's what we call heating or overheating, so they're melting, and then there's a degree of recrystallization or underheating, undercooling as it's called here. So the porphyritics are the ones that experience some heating, there's been some melting, but the original crystal, the crystal structure has remained intact below that sheen on the surface. The barred olivine, or these odd barred olivine types, have melted, but they've started recrystallizing. And there's a degree of recrystallization on that surface as well, which generates those characteristic lines associated with barred olivines. And then there's the final glassy ones where there literally is no, it's melted and then re-solidified without any recrystallization or minimal recrystallization associated with that. Okay. And then the one I always want to find, which is just below scroaceous, which is the unmelted. Okay, it survived. I should point out as well, it's been estimated of the meteorites that enter the atmosphere, micrometeorites that enter the atmosphere, only about 20% survive, about 80% burn up, okay, in the atmosphere. Now that's important when I talk about some of the properties of these, because this material is providing chemical composition or chemistry to our atmosphere stroke surface, oceans. So iron, magnesium silicate is burning up, it's not re-solidifying, but it's still raining down, okay, as those elements of material or particles to the atmosphere. But in addition, so this is a close-up of that porphyritic. You can see these nice crystal structures here, and there's a thin drake or mount over the top. But can you see as well that you've got this other material here? These are called dendrites, okay? These are surface features. And what these are is iron oxide, which during that melting process has separated, phase separation, and has recrystallized, okay? But it recrystallized as these dendrites of iron oxide. And make great social media posts around Christmas, because they look like little Christmas trees. Okay, so I may have put out a post on that, okay? But secondly as well, what happens if you've got really highly melted, and they don't have to be vitreous, is you may get complete phase separation of the metals. So you get these little metal beads, okay? And these metal beads are typically iron nickel in composition, but you can get, in rare cases, platinum group elements. And this is kind of exciting a little bit because, you know, all the rare earth elements, platinum group elements, how important they are in the energy transition or modern society at the moment, okay? This is a little bit of an indirect way of measuring or working out what kind of platinum group elements or metals are potentially available out there in the solar system for future exploration, stroke, mining, asteroid mining, etc. in the future. Okay. A bit of a big leap there when it comes to the future, but it can provide some information there as well. Okay. As I said, the majority of the urban micrometeorites are these silicate type, and in fact, just generally. So if you go to Antarctica, all these other big collections from out of the ocean floor, or Antarctic precipitation, vast majority are the silicate type. Because this is what the original material is, okay? It is cometary material, old asteroid material that's just broken up in the early solar system, okay, that's floating around the stars. And majority of that was silicate composition, okay? But there are other types. The other main group is the iron type, okay, a bit like iron meteorites, okay, and there's a G type, okay, which is is somewhere between silicate type and iron type. Okay, G stands for glassy, okay. It's rather misleading, but anyway. So there is another main group called the iron types. And if you go to the Antarctic micrometeorite collections, okay, you will find a certain percentage of the total population, I can't remember the exact number now, is I type, okay, of micrometeorites. So in theory, we should find those in the urban micrometeorite collections. So on my roof material, I should find I-type micrometeorites. Why don't I? Well, they have been found, but they are very, very rare. Okay? And the reason is it all comes down to signal versus noise. Okay? I can spot S-type micrometeorites because they have a unique structure to them. I-type micrometeorites look just like micrometeoroids. Okay? And that is anything we do that cuts metal, or welding, cutting metal, or just braiding metal, brakes, they all generate spherical iron oxide balls, and they look just like I-type micrometeorites. So I could go picking. I pick out, and what I did when I first started this, okay, I picked out thousands of micrometeoroids, okay, before I found my first micrometeorite, because I just did not know what I was looking for, and I was picking out my shiny stuff. Oh, that looks nice, pick that out. Oh, that looks nice, pick that out. It was all this wrong material, okay. And once I eventually found my first micrometeorite and I knew what to look for, okay, you can read any number of publications and online stuff, okay. It's not until you've actually done it yourself do you realise what you need and what you don't need. Okay? So before I let students loose on this project, I actually did the whole thing myself. It took me 6 months before I found my first micrometeorite. Okay? And I found loads of these rocks. Okay? And that's why we don't, there has been one or two urban micrometeorites found, iron-type micrometeorites found, but as I said, they are, you're looking for a needle in not only a haystack, but a haystack that is in another 20,000 bigger haystacks. They're there, you just really struggle to find them. Okay. And what are these micrometeorites used for? Well, there's a whole range of things. I'm not going to go into the details of the science, but there's information, especially when it comes to fossil micrometeorites, to point out as well. They're not just a modern thing, you can find them in the fossil record. So the students looking for them in fossil material. And they've been argued they've been used for a whole range of things. So some people argue some of the origin of life material, that, so some of the carbon that arrived on carbonate material or carbon material that arrived on Earth could have been from this constant rain down of the micrometeorites, because they can contain carbon or carbon compounds within them. To studies, even modern day studies, so this is one that's really interesting me at the moment. They're constantly raining down and adding nutrients to the ocean. So for ocean's productivity to work, it must be fed by nutrients. And a lot of that nutrients comes from the Earth itself. So from, you heard of Sahara dust storms, they blow dust into the oceans. That's a real source of nutrients, okay, especially iron, into the oceans. Okay, and that's what phytoplankton, etc. use as part of their process. It's been found that actually extraterrestrial micrometeorites are actually probably contributing to that ocean flux as well. Okay, now and also in the geological past. Okay. So they have lots of interest with respect to their scientific. This one really interests me as well. Middle division meteorite flux in the Earth. This was really interesting because of this breakup of this L-type chondrite parent body. For a period of time, it's been argued that actually planet Earth had a ring, okay, because this meteor body came so close to the Earth it entered the zone, the L zone, where the gravitational pull broke up the body, and you actually had for a short period of time, had a ring system around it. It's great paper, if anybody wants it, I can give you a copy. But that ring system then fell down, okay, to Earth, and part of that was micrometeorites, but also part of it was larger meteorites as well. So they have fun parts to them as well. But as I said, this is not a topic that is solely connected with the scientists, okay? As I said, majority of the research that's done in this field is done by citizen scientists. So there's lots of support pages out there. So there's the Project Stardust, John Larson, who was one of the original finders of the micrometeorites. You can join these groups, you can learn information from them, etc. And these are 2 Facebook ones, but there's also ones on Instagram, TikTok as well. And then maybe a site on TikTok and Instagram called PlymouthMeteors.com or Plymouth Meteors in case you're interested. Okay. And to help with that few months ago, with that drive to get people involved in this, for a laugh, it turned out, or it wasn't a laugh, it turned out to go a little bit viral. I decided to create a video of how you can look for micrometeorites at home. So I got a pair of Google glasses and I created this video. It does have a soundtrack to it, but I'm not going to play the soundtrack. Okay. But this is how you can look. That's my dog, by the way. How you can take material from your gutters and using just household material, you can prepare that in such a way that you are concentrating up micrometeorites. So what I've done is I've taken that and I've just sieved off the bulk organics, and now I'm going to the finer organics. I can say my wife and kids were in Ireland at this time, so I was using this bowl without permission. Okay, doing a little bit of somebody asked me if I'd found gold. I said, no, I wasn't panning, it's a different thing. But you get it, you concentrate it up, you stick it on a piece of paper, as I did here, okay? Strong fission magnets. This was a slightly different process, but double bagged, going over. Okay, drawing out the magnetic fraction, sticking it there, okay, and then in this case I put it into a jar, and then I loaded it up onto a tray, stuck it under a microscope I have at home, okay, it's just a standard Olympus low power microscope, and they're the wrongs, that's a micrometeorite, which I found, okay, and then I just picked it out, okay, I don't have an SEM at home, I brought it to work to get this image, but then you can get these amazing images and stuff. Okay, and I posted that on TikTok and got 500,000 views of that video, and lots of comments. Okay, as you can imagine, some of those comments were really supportive, some of them were just woo out there. Okay. Which I kind of ignored a lot of them, and then I got a bit frustrated with the trolling, so I started answering back. Especially when they told me what I was looking at was just rock material from my roof. And I pointed out that I was a geologist and I knew the difference between a rock and a micrometeorite. In a couple of cases, people apologise. I'm really sorry, didn't mean to call them into question, but yeah, if you're interested, there's lots more material on this on my. Okay, this is TikTok. Some of you may not be on TikTok. Okay, some of you may be, but there's also information on my website. And I've only talked about 2 bits of this. I've really talked about the meteor cameras, and I've talked about micrometeorites, but there's lots of other stuff I dabble in that you may want, if you've not looked at already, you may want to look at. Including, if you're looking at the one to look for meteors and you're in the southwest when it's cloudy and rainy a lot of the time, there's a whole other way to look for meteors, which is radio meteor detection. Okay? And I'm not an expert in that, but I've got lots of information. I built my own YAG 3-bit antenna, pointed at the Graves radar in France, and yeah, I regularly detect meteors entering the atmosphere just by using the radio waves to do that. So there's lots of different ways of doing it. Okay. So thank you very much. I hope you enjoyed my talk.